You have likely seen a small column of dirt dancing across a hot parking lot on a summer afternoon. On Mars, these exact same swirling columns can tower 8 kilometers into the atmosphere, nearly the height of Mount Everest. These vortices are often mistaken for tornadoes, yet they function under a completely different set of thermodynamic rules. A tornado is a top-down event, descending from a violent parent storm cloud to the Earth. A dust devil builds from the bottom up, triggered by a column of solar heat radiating from the soil on a clear, sunny day. The swirling dirt is the visible exhaust of a dynamic engine, powered entirely by stored solar energy. This engine requires 2 specific starting conditions: cloudless skies and flat, barren ground. These surfaces, like a desert floor or a stretch of asphalt, spend the day absorbing intense solar heat, baking the air sitting directly above them. Less dense hot air escapes upward. A superheated pocket soon punches a hole through the cooler atmosphere above. Surrounding air rushes in to fill the vacuum and begins to rotate. As the column stretches vertically, the spin accelerates through angular momentum. As long as there is hot surface air to feed the base, the vortex sustains itself. It becomes a thermal chimney, capable of lifting tons of material into the atmosphere. On Earth, these chimneys can grow into severe physical threats, reaching 300 feet across with 75-mile-per-hour winds. They've caused documented structural collapses and pose a lethal hazard to paragliders and light aircraft. The kinetic energy of the wind is merely a carrier for a much more invisible process. Inside the funnel, millions of jagged grains of sand and dust are caught in a violent grinding match, constantly colliding and scraping against one another. This friction triggers triboelectrification, transferring electric charge between particles. The vortex becomes a giant, airborne Van de Graaff tenometer, producing fields exceeding 10,000 volts per meter. Whipping in a circle, these charged particles also generate magnetic fields, fluctuating up to 30 times each second. The spinning funnel operates as a massive, airborne electrical generator. On Mars, this generator operates on a planetary scale. The Martian atmosphere features a much thicker planetary boundary layer, the zone of air influenced by the ground, allowing these thermal engines to scale up dramatically. These Martian dust devils can reach heights of 8 kilometers, easily towering over the most powerful tornadoes on Earth. They leave a massive physical signature behind. Long, dark, twisting trails crisscross the Martian surface, where the vortices have stripped away the top layer of bright dust. These vortices regulate the entire Martian climate. By lifting up to 30% of all atmospheric dust, they directly influence global temperatures and water vapor levels. For our robotic rovers, these vortices create a precarious balance between destruction and salvation. A direct hit can wreck sensitive cameras, yet the same swirling winds have repeatedly saved missions by scouring accumulated dust off solar panels, instantly restoring their power. These electrically charged dust engines are a dominant force in shaping the Martian environment and our ability to explore it. Back on Earth, the cumulative impact is just as significant. Every summer, the small dust devils twisting across our deserts loft 3 times more dust into the global atmosphere than massive, sweeping sandstorms. This means that millions of tons of friction-charged microscopic particulates will eventually drift back down to the surface. This dust often settles on vital infrastructure, specifically the exposed ceramic insulators and metallic terminals of outdoor power transformers. While dry dust appears harmless, this fine film changes how the insulation handles voltage, significantly dropping its resistance to current. The dust has quietly transformed a passive piece of infrastructure into a ticking time bomb. The catalyst arrives with seasonal moisture. Early morning fog or light rain mixes with the settled dust, creating a weakly conductive film across the equipment's surface. Instead of staying contained inside the core, electrical current begins arcing across the dirty exterior of the insulator. Engineers call this surface tracking. This uneven electrical stress etches permanent branching tracks into the insulation. These tracks degrade the material over time, creating a path for larger discharges until the entire system breaks down. The ultimate result is sudden, catastrophic failure. Entire sections of the power grid can go dark because of damage that started with a few grains of dust. The next time you see a tiny swirl of dirt on a summer day, remember, you are watching a charged thermodynamic engine. It is the same machine that regulates the climate of Mars, and it is the same force capable of quietly